Okay, now that we're done with creating the guide rig and putting everything together, what comes next? There's one thing that I want to show you before we move on to create the rest of the rig, and that's how to test for correct placement of joint locations, or the pivots around which each articulation is going to rotate. And I'm going to use as an example this area that we've left kind of like in a weird state, which is the shoulder area. And the reason is the clavicle is pointing towards a more accurate, anatomically correct location for the pivot of the shoulder. However, our original joint is located in a different place. So how do we know which one would be the best to use so that we can correct the other one? Well, there is a very easy way to test for this to see how it's going to deform the mesh. And we don't actually have to bind anything to the skeleton, which we don't want, of course, because this is just a guide. So we're going to take advantage of a very powerful feature in Modo, which is weight containers, to test and see if this area is going to deform properly. So what I'm going to do is we need to create a temporary pivot point to rotate around. And in this case, I'm going to use a locator, which is going to be this guy. And I'm going to set it to match. And I'm going to drag and drop it over to the shoulder joint. So now it's matched to that joint. And I'm going to change its appearance a little bit, make it slightly smaller. And I actually want to make it also a sphere, just so that it's easier to select. And let's make that sphere smaller. There you go. So that's going to help us visualize our rotations a little bit more easily. Now, I want to see how the whole arm rotates around this particular location. So what I'm going to do is I'm going to create a weight container that I'm going to use to rotate this entire arm. So how do we do that? Well, first I'm going to go back to my group and make sure my geometry is selectable. So let's go to the assembly, make this default. Now we can select them again. Go back over here. We can select the mesh. And let's select some vertices. Middle mouse button to select the ones on the back facing area. So let's select this area, okay? That looks okay. And we're gonna create a weight container with those vertices selected, which will immediately assign the vertices to the container. Okay, so now that that's done, let's do a little bit of wiring up the deformations, and we're going to use the schematic for that. Don't worry, the schematic should not scare anybody. It's pretty friendly, and we're going to be heavily using it later on in the course. So what we want to do is we want to add this weight container, which if you double click on the input socket, you'll see that the mesh is already connected to it. And we're going to add our locator. Okay, there they are. So for the locator to drive the selected vertices, the vertices contained in the container, we need to use an influence. So I'm going to select the container again so that the influence I create is already wired to it. And I'm going to go to add the form item general influence. And as you can see, it comes wired up. And the container is the incoming geometry for the influence. And now I'm going to just wire the locator in setup mode over to as the effector. Okay, so now when I exit setup mode, I can take this locator, and if I rotate it around in local mode, you will see that it's transforming the vertices. So what I'm going to do is I'm going to work on this area a little bit just to make it less distracting, so we can actually evaluate the deformations a lot better. So I'm going to select my container, go to the weighting tools, and I'm going to use the scale down brush and scale it so that I can actually take off weight from those vertices. I can make this a little bit faster. just so that we get a better idea of how this area is going to actually deform based on the effector we're using at the location of the shoulder joint. So let's say that that's it. We don't need to really fine-tune the deformations at this time. We'll do that when we actually start weighting the actual deformations on the mesh. I just want to get in the ballpark. So once that's done, drop the tool, and let's reselect our locator, rotate again. So that's what we get at this point. Okay. So now we need to compare with the other location, which is the end of the clavicle. So let's go back to our schematic view and let's unwire this. The mesh is going to go back to its original state, which is great. We don't need to take too much care about getting the locator back to its original position. And now I'm going to take the locator, and first I'm going to match it again to the joint, so the rotation goes back to the exact rotation the shoulder joint has. But now I'm going to set my drop action to match position, and I'm going to drag and drop it to the end joint at the end of the clavicle. So this is going to get me the position of this guy, but with the actual orientation of this bone. Okay, and let's test for rotations at that location. So all I have to do is enter setup mode, rewire the effector, which is going to put everything back into place but with the new location, and I can rotate the locator and see what we get. So as you can see, based on the deformations I see from here, this is a much better location for our rotation pivot for the shoulder area. Okay, you get more natural more natural deformations over here, and also in the armpit area. So we're going to adjust the arm of the character to match this location without disturbing most of the work we've already done. All right, so with that said, let's fix the arm of the character. Okay, so now that we've determined that it would be much better to have the arm rotate from this position over here, how do we get it to start over there without losing the rest of the work we've done? And one thing you could do if you want is to just rebuild the entire arm like we've done it before. It wouldn't take you too long to create 3 joints, but what I'm going to do is I'm going to show you an approach that might come in pretty handy when you try to fix things like these. Okay, so let me show you how it's done. The goal is going to be to get the arm to start from this position over here without losing the pivots that we've already established, which are this pivot right here for the elbow and right there for the wrist, so that we match the position of the hand joint, while at the same time ensuring that the arm stays on a single 2D plane, which means that this joint over here has no rotations with relation to its parent except this little angle that allows him to bend forward. The rest of the rotations, the 2 remaining axes, have to remain at 0. Okay, so let's see how we do that. So we're gonna create first a couple of locators. We're gonna use the first one as reference. I'm gonna create one locator here, set my drop action to match, and I'm gonna drag and drop it onto the elbow joint. And let's make it a little bit smaller so it's easier to see. So this guy is just going to be our pivot reference for this position. This is where we want to make sure the elbow goes back to. Okay, and we're going to create a second locator that we are going to use to manipulate the entire arm chain, and we're going to position it again with a match drag and drop operation to the new position that we want, but we want to have it aligned to this first joint, and you're going to see why in a second. So I'm going to set my drop action to match rotation and drag and drop it onto that guy with the right mouse button. You'll see me do that a lot. I do it a lot of drag and drop with the right mouse button directly in the viewport, so I don't have to find things in the items list. And now our locator is perfectly aligned with this joint. It's just at a different position, okay? So the plan is going to be as follows. I'm going to use this guy to drive the entire arm chain so I can rotate it into new orientations. However, I don't want to disturb the hand as I do that. So I'm going to grab the hand joint. You can see here it's the hand. And I'm going to unparent it with compensation on, so it stays in place. It's an unparent in place operation. So we're just throwing it out of the hierarchy, so we don't do anything that might affect it. It's going to stay right there. Okay, so the first thing we're going to do is we're going to realign the joint chain towards the elbow area. Okay, so that's actually pretty simple to do. What I'm going to do is first we're going to take this joint and move it onto the new position. So we're going to set our drop action to match position, and we drag and drop it into its new position, and now it's up there, okay, starting from the right place. But as you can see, that threw the rest of the arm out of alignment. So we have the elbow up here, the wrist is at a different location. So let's fix that. So the first thing we're going to do is I'm going to take this guy and parent it over to the locator, okay? It doesn't matter if I use compensation, because right now they both share exactly the same local space. So when I do parent, this guy's transforms should be all 0 because it matches its parent space perfectly. So that's good. And now what we're going to do is I'm going to aim the arm towards the old location of the elbow, okay? So how do we do that? That's very simple. We're going to use a direction constraint. So I'm going to take this guy, shift select the locator on the elbow area, turn off compensation, go to modifiers, and use a direction constraint. Let's go to the direction constraints parameters and change the axis to X, because that's the axis we've been using so far to go along the bone. And now the bone goes into its same orientation, except that you now can see that we are aligned towards the old position of the elbow. So now what I can do is take the elbow joint, okay, and just drag and drop it onto the elbow locator, and it goes back to its original position. And as you can see, the rotations are still zeroed. That's because we took care of aligning everything properly before doing the constraint and the movement. Basically what we did was, because the locator was aligned to this joint's orientation, when we moved the elbow joint, it moved along its parent's local x-axis. So that's the only thing that changed. So we can keep our rotation 0 the way we want it. So that's done. The wrist is not done yet. So as you can see, we still have an offset there. So we're going to do basically the same. We're going to use the direction constraint. And we're going to take a sort of like IK-ish approach here, without really using IK, but you're going to see in a second what I mean. So the first thing I'm going to do is take the arm joint, and then now it's at the proper position, and let's unparent it with compensation on, so it's an unparent in place, it just stays there. And we're going to take this locator, and this time what I want to do is I want to make sure that I take this position of this joint over here, which is the end of the arm, and I move it over to the position of the hand bone. So we cover this little area over here. That's going to throw the elbow out of position again a little bit, but we're going to fix that afterwards. But let me show you how this is going to work. So we take this guy, let's find it over here, here he is, and we're going to delete the constraint because we don't need it anymore. And now the first thing is to aim him towards the end of the arm chain, which is that joint over there, and turn off compensation, again direction constraint, and change the axis to X. So now he is pointing towards that area. Okay, so that's great. Now I'm gonna constrain him over to that joint with the direction constraint, so he moves over there. We need to get rid of that constraint. But since we want the arm to move with it, I need to parent the arm with that locator. If I try that right now, you are going to get an error. Let's turn on compensation. Let's just try to see what we get. Say parent in place, and Modo says, oops, I detected a dependency loop. And what that means is Modo figured that you were trying to parent this joint to this locator, but this locator has a constraint to an item that is part of that hierarchy. So you're basically getting into a loop where Modo would not be able to resolve the final transforms for all the hierarchy because there are interdependent objects being linked together. So Modo is smart enough to figure out that you're trying to do something that is going to put the entire application in a really unstable state. You're basically going to go into an infinite loop where you would never get out of the parenting operation. Modo would just freeze. So Modo does not let you do this to prevent you from getting into such a problem. But that's pretty easy to resolve. So before parenting this guy, I need to get rid of the constraint. So let's just select the locator and delete the constraint. And oops, we have a problem. The locator went back to its original orientation, and we don't want him to do that. So let's undo that for a sec. We want him to keep this current orientation towards this end of the arm. The reason why it did that is because internally the locator has a set of transforms stored. Okay, the transforms you're used to seeing over here. These transforms are currently being overridden by the direction constraint. Okay, the direction constraint is taking control of the item's rotation and dictating how that should go. However, once you get rid of the constraint, it goes back to the transforms stored in here. So what we need to do is to be able to take the current world transform of the item and store it as its new stored transforms. Okay. And fortunately, Modo can do that. What I have to do is select the item and go to the Animate menu and say Apply Rotation. What this is going to do is to take the current world rotation of the object and store it internally as its local transforms. So let's see if apply rotation. I go back here. The values have changed. And now I can take the constraint over here and delete it. And the item will not move, will not rotate. So you can do that for either positions, rotations, or scales, or basically everything. And that way you ensure that deleting afterwards modifiers is not going to have a funky effect on your item. Okay, so now our item is properly oriented. It has no dependency towards this chain. So now I can parent things together. So the arm to the locator with compensation on, parent in place. Good. Now we're going to take the locator again, and this time we're going to aim it towards the hand joint. Okay, we turn off compensation, use a direction constraint, go over here, change the axis to X, and now our arm is properly targeting the wrist area. Okay. If you look closely, let's go back here and frame that, you will see that we still have an offset from the wrist over to the hand bone. And of course, now we have an offset over here at the location of the elbow. And that's because we rotated the entire arm chain. So let's fix these two things. At least we're pretty close now. To avoid having visual problems, I'm going to hide parts of the rig that we don't need, like the two thigh hierarchies, no more legs, and we can get rid of the other side of the other clavicle. So let's hide that one. There we go. And we can also hide the there you go, the head and all that stuff. So we just keep the arm and part of the spine. I cannot hide these guys because hiding an item also hides its children. So I'm just going to keep them there. I believe there's a way of a preference to override that, but I'm not gonna mess with that right now. So we need to move this guy to the locator's position, okay? But you know we cannot use a move tool because that's going to throw the other joints in the chain out of alignment. We've seen that happen before when you use the move tool and you move a joint and the parent is not pointing towards him anymore and he's not pointing towards the child anymore. So we want to definitely avoid that. And the only way to do it is by using the skeleton tool. However, the skeleton tool can sometimes be a little bit touchy. Like right now, for example, if I have this joint selected and I go and turn on the skeleton tool, okay, let's select just the joint again, and I move things, you'll see that they just pop out of place. And the reason is, well, remember we have a work plane that in Modo that dictates how things are constrained when you edit them. So well, right now we cannot see it because we are in the setup layout, and the setup layout has it turned off by default. But if we turn it back on, you'll see where the work plane is. So our joint in this case was popping over to the work plane and sticking onto it. And we don't want that. We want it to remain like this. So there's actually a way to do it very easily. We can align our work plane to any object in the scene. So I could align it on a plane that allows me to work on this joint. But remember, because we want to retain the planar nature of our arm chain, I don't want to align the work plane on this joint precisely to work on himself. I want to align it on its parent. So let's select its parent and say align work plane to selection. And now the work plane is aligned to that joint. So now I can move this guy, making sure that any movement that I do using the skeleton tool is going to remain constrained to that work plane. And to make things a little bit easier for me, so I can properly align this, I'm going to jump to a top view, which now is from the perspective of the work plane. And I'm going to zoom in and turn on the skeleton tool. And I'm going to move the joint over to the location of the locator. And you can continue to zoom in if you want to make sure you get the right spot. There we are. Now we can exit. And now we have our joint sorry, properly positioned at the location of the locator. So let's drop the tool. And now let's take a look at the wrist joint. We're going to do the same thing over here, except this time we're going to align this guy. So we want to use his parent, which is this joint over here. So we align the work plane to that object. And now we are here. And we're going to align the end joint in the chain to the center of the hand joint. However, we cannot see it very well right now because it's a sphere. So we're going to go to its display properties, and the locator shapes change replace to add. So it keeps the spherical shape. We can also see the locator at the center. And now we select again our locator here. I mean the last joint. Turn on the skeleton tool again and move this guy over to the center of the hand joint, which is right there. There you go. So that ensures that this joint keeps pointing properly aligned in that direction. We drop the tool and let's go to a perspective view just to examine everything. Make sure that everything is in position. This looks good. And that over there, we still have a little bit of a gap, it seems. Let's check that out. Let's see our properties. It looks like I've selected This is the locator, this is the joint. Because we used the skeleton tool, now we have to merge the channels. But before I do that, let's make sure that everything's okay. Yeah, we still have that gap over here, but the reason is because we shifted the parent joint over to a new position which is higher. Now we don't lie on the same plane that the locator, the marker locator we have, is on. So it doesn't matter too much as long as from a top view we are aligned with the other two axes, because if we try to align this guy back over to the locator, which is up here a little bit, as you can see, if we move this part up, then you would see that we don't have anymore a plane for our arm. We would basically break the bone right there, break the elbow. So we don't want to do that. You can ignore any offsets you have, in this case in the y-axis. So we just want to make sure that everything stays on a plane. So that's fine. The elbow is still at the good location in this coordinate, in this plane, which is the one we've been actually trying to keep things planar on. So we can just go and start merging our transforms. So we're going to merge this guy to this guy and delete the secondary. Let's now select the next bone and merge this guy to this guy. And again, delete the secondary. And we'll do it for the last joint. Delete the secondary. And we're done. Now we're going to reset the work plane. Our arm is fixed. Okay. So we can pretty much just take care of the other side. We're going to mirror it, of course, to fix the other arm, which we cannot see right now. But first I'm going to go back to the hand joint. And let's change back its display property to replace, so we get rid of the locator. So now it's there. Good. And let's mirror the arm. To do that, first let's check where this guy is. Okay, he's still a child of the locator, so let's unparent him in place. Now we're going to take the locator and delete the constraint it has. And we're going to reset its rotations. Reset rotation, so it gets aligned to the world. And now we're going to select again the bone and parent it to the locator in place. And now we just select the locator and do a mirror hierarchy. We get the entire arm over there. Of course, get rid of the negative scale on the locator, and we have our new arm right there. Okay. So if I unhide the rest of the rig, you will see that it matches. It matches the hand position that we have for this side. Of course, we still have the old arm over here, so we're gonna get rid of that. But first, let's unparent the hand on this side. Again, unparent in place. Now we take the old arm chain, and we can just delete that because we're going to use this new one. Okay, so we're almost done. Now what we have to do is parent this guy to the clavicle in place. Same thing for the other side. Parent in place. There we go. Okay. But there's one more thing we have to check. If we grab these two joints right now and turn on local rotations, remember that we want them to be symmetrical in their transforms too. Right now they are not. You can see that they're going in opposite directions in Y, opposite directions in Z, and it's only the x-axis that works fine. So we need to fix that, but we already know how to do that. So let's just select the entire joint chain in this side, bring up our Align tool dialog, and we're going to use XY and on a Z up axis with negative scale. We know that that's what works for this side. We get it done, and that's it. So let's check again our rotations. Z is fine. Y is fine. And X is okay. So we're pretty much done. All that's left is cleanup work. Let's make sure that first we name this side properly. So right now it's called joint R upper arm, and let's see what side this is. So we need to replace the R's with L's and get rid of the suffix. And let's do that for the other joints in the chain. Let's get rid of the skeleton prefix, L, arm, and lastly this guy over here. Get rid of skeleton, L. There you go. So that's done. Is he parented to the clavicle? Yes, he is. So now we can take these locators and delete them. This guy, this guy, and this guy. Let's make sure they are not part of any hierarchy. No, they're not. Let's delete them. And we're done. We just have to reparent the hands. So this guy is going to be parented to this guy. Compensation, parent in place. And we're going to parent this guy to this guy. Actually, before I do so, I need to align those. Sorry, forget about that. So let's unparent this guy again. Let's take him and reset its rotations. There you go. Now it's aligned to its parent. Same thing with this guy. Reset rotation. Now he's good. Especially him, because we use the align tool, so he would have problems. It looks like we have a little bit of a rotation here. That usually happens when you use the align tool. So let's take this value over here, copy it over to this side. There you go. And it looks like we still have a little bit of an offset there. So let's see why that is. First, let's make sure that the hand bones are exactly at the same positions. You should see no change in these values except on the x-axis. That's fine. And that means that the rotation is probably coming from here. So let's review that. So this guy has an x rotation, well, x position. There's a few millimeters there. But we want to read these rotations, minus 73, and actually we're going to copy them over to the, let's bring up Notepad. And I'm going to paste them on the other side. So let's do copy this guy, copy the next one, and lastly this one. Okay, and we're going to paste them over to the other side, and there's going to be one that is going to be mirrored. We'll see which one that it's going to be. It's apparently going to be Y. Let's see. So we'll copy the first one, we paste it here. We copy this one and paste it here. And we copy this one and paste it here. There we go. And now it's aligned back in place. And we have matching transforms. So be sure to check that every time you use the align tool, because the align tool will, since it resets the axis, it also resets the joints in some orientations, especially when they are not oriented exactly orthogonal to the world axis. So you might want to review that and copy and paste transforms as needed. So that's it. It looks like at this point we're ready to roll. Let's just make sure we're back in our proper rotations. everything's good. Now we just quickly reparent the hands. This time we should be okay to do so. And we're done. Let's just unhide the legs. And let's get rid of the work plane. We don't need it anymore. And that's it. We've fixed the arms. This is an approach that you can use to fix pretty much anything when you're rigging. So it was all just based on constraints and using helper objects like the locators to move different parts of the hierarchy where we needed them. So I hope it was all clear and not too confusing. And let's just move on to the next part of our rig. Okay, see you there. I want to go very quickly over something that we have in the rig that is a little bit of a problem. We have a little residue transform happening on this joint. If I select this joint, you will see that it has a Z position value when it actually shouldn't. The only thing we should see on this joint, it's an X position value, which means the distance from him over to his parent on X, which is the axis running down the bone. And that's all we should see. We don't want to see any other transform values. And the rotations are the same. We just want to see one angle. So that means that this guy is actually offset on Z, whereas it should not. If I change this to 0, you'll see what happens. This moved a little bit. And of course, the hand's now out of alignment. So we're going to quickly fix this. Always do a double check on everything you're doing to the guide rig before moving on. We're going to quickly fix this and then fix the other side. So this is going to be actually simple since we've taken care of aligning everything already. So I'm going to use exactly the same approach. I'm going to create a locator and match it to this guy. Okay, and I'm going to unparent the hand again, just to make sure we don't affect it by the changes we're going to do to it right now. And I'm going to select this joint and set the Z position to 0. So that's going to shift the arm a little bit. But now we're going to take care of fixing it. We're going to take our locator and aim it at the end of the arm using, again, a direction constraint on the x-axis. Okay, now he's pointing towards that. Again, we're going to store those rotations. So we apply them, and now we can get rid of the constraint. Now we're going to parent the upper arm bone or joint to the locator. Let's turn on compensation and parent in place. And now we're going to again aim this locator towards the hand, which is over here. So turn off compensation, direction, X, and we're done. Now everything is pointing properly again. We have no more offset over here, only one rotation. Of course, that means we actually reoriented this bone, so the rotations, the values are going to be different. We're going to see that in a second. But for now, I can just reparent it over to the clavicle and delete the locator. Okay. And now all we need to do is copy the transform values again. So let's grab again our notepad. And let's take these rotations. And 24, 25, 75. But this guy over here seems to be okay. And we have a little bit of some really small position values over here that I'm going to get rid of. And yeah, it looks like the other side didn't have that problem, but let's fix it anyway. Here it is. It's because it happened at some point during the fixing and mirroring process. So we're just gonna copy these values over to this guy, and that should fix everything. So let's copy this one. Oops, I think I pressed the wrong hotkey. There you go. Now this guy. And lastly, this guy. There you go. Yeah. Now everything is okay. Let's double check again. We should see no visible changes except positive, negative signs. We have a little bit of a difference here on the X value, so let's just copy that too. Oops. It has to be negative. There we go. And now everything seems to line up nicely. This guy also has a little bit of a problem over there. And we're going to take this value also and copy it to this joint. I think it's the same actually. There we go. So now we have a nicely mirrored rig. And because we used the skeleton tool on this side, sometimes the skeleton tool prefixes the skeleton word over the joint's existing name, so we can just get rid of that. This guy, I fixed the names manually, so nothing over here. And we're good to go. Let's just reparent everything. So the hand over to this joint, parent in place, the upper arm to the clavicle. We do the same thing on this side. And lastly over here. Good. So we fixed the guide rig. We can move on over to start the arm rig.